on Daniel and the football frog, right? What was he thinking about when he was building that technology to keep the frog moist? What was he really thinking about the frog? Something about the frog.
He was thinking how much water he would need to make the technology.
Exactly, how much water he would need, right? And how did he compare that to the frog's membrane? How did he compare that? Nathan?
He went to the rainforest to see.
So he looked at something in the rainforest to inspire his technology. What do you remember what the membrane does? Do you remember what he learned about the membrane doing, Nick?
It keeps out, well, it brings in air and water, and it keeps out like rocks and different. It's like it shields that out.
Right. So it allows some things to pass through that the frog needs, his basic needs to stay alive, and it keeps out the harmful things that won't allow him to get, infected or something like that. So we all have basic needs, right? And so the membrane actually helps him get his basic needs. Would you agree? Okay, do you think we have a membrane in it? I think we talked about this the other day a little bit about membranes, somewhere like in our stomach. Do you remember that? All right, how does that work? We don't really know how that works. We kind of have to imagine that. Abby.
I think after you drink the water, it'll go to your stomach and it'll travel through like your veins and go to the spots, so your skin will just dry up.
All right, so your skin will dry up, right? Okay, so today we want to think about a membrane. We're going to use a raisin. We're going to look at raisins today and think about them, the outside of the raisin, just like a membrane. Okay, like the frog's skin or like our stomach lining or some kind of membrane that we have. But the first part of the question I want us to think about today is this. What are some properties of natural membranes? Okay, we're going to look at a real natural membrane and figure out how does this thing really work and how is it good for meeting a basic need. Okay, we're going to look at 4 different raisins today. 4 raisins. So you want to put this into 4 parts, okay, and label it. And this is it's labeled raisin number 1. There are 3 raisins inside. I want you to really dissect it. It's just a raisin. You've eaten raisins before. Really look at it really closely. We want to see what you notice or all the properties of this raisin.
I want to eat it. Raisins are just it's more that wrinkle, brown, mushy. Does it look like it has holes?
It doesn't have any holes.
Am I the only one who doesn't see holes?
I don't see holes either.
Mine doesn't have holes.
And its skin, I don't see any holes.
You saw holes? Really? Interesting. Can you show me a hole? I have some good glasses.
Right there.
So there's one hole? Yeah. Oh, it has one hole. Do you think that's where the stem was? Maybe. Okay, guys, how about this? How long was the raisin in water for raisin number 1? Nathan, it was not in water. Do you see holes in the raisin membrane? Did you guys see holes? It's an interesting conversation. Nathan, did your group see holes?
No.
Okay, Nathan says no. Did any other group figure no or say, I didn't see holes in there? This group said no. This group said no. Who saw holes with your eyes? Okay, you think you did. You think you did. Okay, tell me how you saw those holes. Look, how many holes did you see?
I only saw a couple.
Just a couple of holes?
Yeah. On one side. I didn't see a lot though.
Just on one side, but not on the other side?
Yeah, I didn't.
Okay. John, okay, I'm sorry. Angelina?
The holes I found were like on the ends of the...
Okay, so do you think maybe those holes or that hole is from the stem of the raisin? You know how the...
Yeah.
What was it before it was a raisin? A grape, okay. Well, how do grapes grow? On vines, so there's a stem, right? So do you think maybe that hole or could be from the stem?
Yeah.
Okay. Overall, do we see a lot of tiny holes? Okay, just maybe a hole or 2. So I'm going to say that many of us did not see holes. I'm going to just put that, but I'm going to just put in the corner a few. Okay, how about that? Is that all right? So everybody's happy with that? Because if you saw holes, you saw holes. What does the raisin look like? What are some of the properties of the raisin? This we should get some really good words. Kendra.
It is in a ball form.
So it's roundish. Abby. Squishy. John. Dry. Okay, are you ready? Are you ready? Okay, so leave that in section 1. Section 2. It's been in the water for 24 hours. Could you record that? 24 hours.
Do you see holes in it?
Yeah, I see a lot.
Because I think it would, because it wouldn't be able to absorb the water without them.
No, yeah, but the stem hole.
No, there's a lot of other holes.
But on this one, we found something else.
What did you find out?
How could it be so big? Because then there has to be holes in it.
Because they absorb the water.
Has to be holes in it, right? How else could it get in there? You see holes there? Guys, don't be afraid to open up your raisin. Good. Who needs one? Prove it to me. Show me. I want to see a hole. Okay, can I have your attention? Please put the magnifying glasses down. So how long was it in the water? 24 hours. All right, here we go again. Do you see holes in the raisin? Yes. Savannah.
My group thought that
because it's so big that it had to absorb the water. So then we saw little holes in it.
Did you hear what he's saying? Explain that again. The raisin was so big. What he makes is they make a great observation here. Go ahead, say it again.
The raisin is so big that it has to have holes so that it can absorb the water.
The water went through, right? Would you agree that water went through that? Okay, so does it have holes? Okay, it does have holes. Can we see them?
With the magnifying glass.
All right, if you have really good eyes like Jaden, you can see them. But don't you think those holes are so tiny it's difficult to see? Okay, they do. Membranes have holes, little tiny holes. They have a special name. They're called pores. Do you know that you have pores in your skin? And, okay, I see it. They're called pores. And things can pass through them, right? Water went through. Would you agree? If it allows that to pass through, they call it semi-permeable. Some things can pass through, okay? What does the raisin look like? What are the properties of that raisin? Noor.
I noticed they got paler than the dry one.
Yeah, it looks lighter, right? So she said pale. It was paler than the other one, and it did start off the same exact color. They're all in the same, they're pretty close. Vivian.
It's bigger.
Okay, it's bigger. Anybody know why it's bigger? Why is that raisin bigger?
Because it absorbed the water.
It got some water through it. Ready? Raisin number 3.
Yes.
Raisin 3 has been in water for 24 hours. But what's interesting about raisin 3 is it has sand in the cup. Now let's see, as you're investigating this, what do we think has passed through that membrane? Well, what do we know has probably passed through it? Water, because it does have little holes in it. Let's investigate and see if the sand passed through.
Let's open it up.
Open it up. You know why? It's pores.
Yeah.
It's pores blocking out the crumbs.
You have to look at them on your plate. I want to get some sand. I'm going to
Yeah, there's sand there.
sand in there.
Yep, I can see sand. I don't see any sand.
Look, use your lens to really see if there's a lot of sand in there, like the water was in there.
Yeah, there's sand sticking to the walls. There's sand sticking to the walls of it, like right there. Sand inside.
Inside, show me the sand inside.
So you have how it has less. It got through the skin.
Go to the other side.
It got through the skin and went inside.
Why are there more
Really? So it went right through the skin all the way into the center.
If you look at it, if you take the insides out, the sand would be inside the inside.
Okay, my little engineers. Did you record in your data sheet?
Yes.
Okay. So it's 24 hours plus sand, right? Okay. Do you see holes?
No.
Okay. Are there holes there?
Yes.
What do we call them now?
Pores.
Pores. Membranes have holes that are porous. They're too small to see. So overall, we kind of come to some agreement about that. Membranes allow some things to pass through them, such as what?
Water.
Water. Okay. Now, is there sand in the raisin? Abby says no. Your team says no. This bioengineering team says no because
Because if a raisin's a membrane only that like water, air, symbiotic bacteria sand can have bacteria on it, so nothing can get there.
okay, so this membrane didn't allow it through. Okay. Julia, what did you say before? I like how Julia was thinking. Julia's kind of thinking the same way Abby was thinking. Go ahead.
I said that because the sand doesn't carry any nutrients for the raisin, what's the point of absorbing it if it's not going to use it?
Did you hear that? So Julia's thinking that the basic need of that raisin, the grape, when it was a grape, right? It certainly wasn't sand. So her thinking is that the sand couldn't go through it because the grape wouldn't need that as a nutrient to grow. I really think that's a great idea to think about it. And let's think about it. When it's a grape, how does it become a raisin? Kiana?
It gets dried up.
From the sun, the energy from the sun, right? The energy from the sun dries it out. What happened? What was in it before it got dried out?
The grape.
What was in it? Why was it round and big? Water. How did the water get out?
Evaporation.
And how did those little molecules escape?
Pores.
The pores. Good. So who thinks there is sand in that raisin?
No one.
Okay, if you do you think it's a possibility that the sand was on the outside?
Yes.
And when we cut it and kind of handled it, we kind of got some sand. Maybe if we rinse them all really well and go inside, maybe we can do that tomorrow. Raisin number 4. It has been in water 3 hours.
Ooh, it looks darker inside. Okay, I think there's holes. There is holes, but I don't see any. Yeah.
It's pretty hard. Yeah, it's kind of hard. It's not squishy. It's squishy inside, but the outside is hard.
Ew, look at the inside.
Yeah, it looks the same thing as 3.
No, not mine. Mine looks kind of like none of them. Mine's just like number 1, but less.
I dissected it. You can see the inside.
He's in number 4. How many hours? 3 hours in water. Okay, big question. Do you see holes? What do we say about this one compared to the one for 24 hours? Nor?
I'd say that the ones for 24 hours, like Angela said, they were very fragile, but this one was a little more tough to make.
Why do you think it's tougher than the one just for 24 hours, Nor?
Because it's less like soggy and creative than the other ones.
Do you think, here's a question for everybody. So would everybody agree with Nora just said, her thinking on that one? Okay, you would agree that this one is a little tougher, more wrinkly. Can I have some properties of this one? Nick?
It's not dark, but it's like it's not the lightest, but it's not the darkest either.
Okay, a little dark. Nick, did that work? Nora said that it was in between, or Nick, somebody over there said, it's in between the dry raisin and the 24-hour raisin. Do we all agree with that? If we left it in overnight and tomorrow morning we looked at it again, what do you think it would be closest to? This one, no water, or 24-hour water? Why would it be close to 24-hour water? Vivian?
Because the dry one had absolutely no water, and raisin 2 had 24 hours, and I think that if we left it for another 20 hours, it'd be like 24 hours.
Okay, So do you think membranes control how things pass through?
Yeah.
They do. They control how things pass through. Because if it didn't control it, wouldn't it be just like the 24-hour one?
Yeah.
But it's not. So we have to wait that 21 more hours. All right. So what have we learned about membranes? Let's visit this right here. I've got one more thing to add, and that would be that you just said that if we left it in, it would get more water. So could we say that membranes control how quickly or slowly things pass through? Would we agree? Good job. And what stage of the engineering design process were we doing today? Ask. We're going to continue asking tomorrow. Engineers?
Yeah.
Okay, so what did we do this morning that was so exciting, that really sealed the deal for us over here from yesterday? Ariana?
We washed the raisins from yesterday with the sand, and we saw the raisins did go through, but
So the sand did not permeate or go through, right? So what do we really know then about that membrane, the raisin membrane? What do we really definitely now know, Kendra?
It only lets in things that they really need.
Exactly. So what did it let in? What did that particular membrane let through, pass through? Kendra?
Water.
Water. And what did it keep out? Kiana?
Sand.
The sand. Okay, so we definitely know that it allows some things to pass through and others not to pass through. As I, walk around and monitor and, engage in conversation, I can hear children saying, oh, I really see those holes. And so I'm questioning, really? Well, show me where you see those holes. I'm trying to get them really to say that they can't see the holes. But some kids are adamant about seeing the holes. And even after I said, well, maybe it's the hole from the stem, they took that, but then they were still convinced. So as we went through the lesson and we got to the raisins in the sand, okay, now they see sand in the raisin. Okay, there really is no sand in the raisin, I don't think. Not that I've seen yet. And I finally had to stop for a minute and say, okay, that's it. Magnifying glasses. Get these magnifying glasses, and I'm passing out magnifying glasses because I really want them to really look deeply inside there. In the end, the consensus was basically most of us don't see those holes, so that they're so tiny that water does pass through and other elements do not. Some were still not convinced of that. So for that lesson, I said, okay, tomorrow, the lesson needed to end. I said, tomorrow we will rinse out, we'll leave them in the sand, we'll rinse them out, we'll cut them open, and we'll really take a good look to see if the sand got in. And that's exactly what we did. The next morning we came in, we looked at those raisins again, and lo and behold, there was no sand, and they were in total agreement that it is definitely semi-permeable where the water came through and the sand did not. All in all, it was a good lesson. It was a very good lesson. It always is a very good lesson. And we did come to some good agreements about the properties of membranes. So that's the goal.